Hello guys, welcome to tutorial 5. So this is the plan for this tutorial is going to be to basically catch up because Mr. Moore has discovered that there is like a slight um, desynchronization between the tutorial content and the lecture content and the assignment content as well. So we're going to try and balance it out by basically going over assignment 3 is the main plan today and taking up pretty much all of it. And if you guys have any specific questions that you guys want me to take up, then you can feel free to mention them and I can do that too. But if nobody says anything, then I'm just going to be going through assignment 3 question by question and showing you guys the solution for them and walking you guys through. So here we go. I've made a copy of assignment 3 right here. And we can just start going through it. So here we have a dictionary. The question says, given a sentence S, produce a dictionary that tells you the number of times each word has occurred in a string. You may assume each word is lowercase. There are no contractions and each word is separated by a space. Please note your function must return the created dictionary. So this one's pretty easy. This was a practice question, mind you, but it was also not too difficult, and we can definitely go through it. So all we have to do here is split the dictionary up, and I'll show you guys how to do that. We can get rid of this stuff. Basically, we can say the words is equal to the split of the sentence using a space separator. And with that, we can also define a dictionary. I think that was done for us. And we're going to be returning this dictionary at the end. So all we have to do in the middle is check to see if that word is in the dictionary. If it is, then we're going to increase the count of it. And if it's not, then we're going to create it in the dictionary. And the way we're going to do this is by going one by one through each word in the sentence. So we're going to say for word in words, if word is in the dictionary, then we're going to increase the value of that dictionary key value pair. So it'll be dictionary at word plus equals 1, right? Increase by 1. And if it's not in the dictionary, then we're going to add it into the dictionary as 1. That's how we're going to define it. And at that point, we should just be able to return the dictionary, and it should be correct. So we can try that out. Compile it there and run some of these test cases. That's true, and that's true. And yeah, once again, this is going to go on Avenue under our tutorial subfolder if anybody wants to look at it later on. And I'm just going to be going through each question. So if anybody at any point has any questions about how I did a certain part of the question or what a certain line meant or did, feel free to ask and I can explain. And then here are some questions that were pretty easy. This function asks us for the span of a list. So it tells us in the question that the span is defined as the difference between the largest, aka the maximum, and the smallest, aka the minimum elements of a list. And thankfully, Python has built-in functions for that. So we can just say diff is equal to the max of that list minus the min of that list, and that's exactly what we're returning. Right, we can run that, it's all true. Notice that we're just defining diff and then returning it, so realistically we could just return this and not use the auxiliary variable at all. So we can recompile that and test it again, and it works fine. Here we have the bound of a list, which once again is defined as a tuple with a tuple where it's 2 elements, and the first is the minimum of the list, and the second is the maximum. So we could just, once again, do pretty much identically what we did up here, but this time it wants a tuple, so we just put it in brackets. We say min of L, comma, max of L. And that should be good. We can test it out, and we're good. What do we have? Okay, So next up is the arithmetic mean of a list. So as you guys know, this is just the mathematical formula for the average or the mean. And that is basically the sum of every value in x divided by n. So n here is the length of the series x, and obviously sum of x is just the sum of all the values in x. So very similarly, we can just return the sum of our list, here it's L instead of x, divided by the number of elements in that list, which is the length in Python. So once again, these Python functions, these built-in functions, are coming very handy because they provide exactly what we need to solve some of these questions. So we can compile this function and run again, and we're good. Cool. I've also been keeping a slide track on what's been going on for Piazza and the questions you guys have been asking. And so just going through it, I can see that there are a bunch of questions about this problem, which is the translation problem. This one's not too bad. Basically, the question asks for you to just return a nested dictionary, right? Such that you can access the dictionary like this. So it's nested as in the outer layer of the dictionary has a bunch of languages that you can select. And then within each of those languages, you can select a word. And that word will either be hello, goodbye, or acute digestive distress. And the 4 languages that you guys are going to code for is German, Icelandic, Japanese, and Polish. So all you have to do for this is just return some sort of nested dictionary, right? So it's going to look like this, and we're going to return that dictionary at the end. But keep in mind that this nested dictionary is going to have, obviously, by definition of the word nested, is going to have dictionaries within it. So the dictionary is going to be made up of a dictionary for each language. And so we'll have something like this, right? German is going to be a key in our dictionary, but the value of that key is going to be its very own dictionary. And within that dictionary, we're going to have the 3 key value pairs for each of these words. So here we'll have the English to German translation of hello, right? Of goodbye, and of this term. And obviously, I'm not going to do this for all the languages because it's pretty much a bit time consuming. But I will show you guys how to do it. It's very simple. You just have to fill each of these by checking in Google Translate as the question specified. Somewhere right here. So you can say, for example, German, and you want to find out what hello is. You go over here, you find German. And if we say hello, it's just this. So you can copy that over, put in your key value pair, and you can see that already in this dictionary, if this was a valid dictionary and somebody put in German hello, it would access this, it would return, it would go into German, and then it would go into hello, and it would return this string. So if this said German hello, this would be hello, this string right here. And so you can already see how the layout reflects what the test cases are going to try and access, right? So pretty much the same process would go for all this stuff. You just find each one, fill it in, and so on and so forth. So yeah, I'm not going to do the whole thing, but you guys get the point. After we finish German, obviously we're going to add a comma because we're going to do our second nested dictionary, and this one would be, I believe, Icelandic, right? And then here you'd have a dictionary as well with each of these, right? So it'd be like this, except you would replace all of these with the Icelandic one, and so on. Obviously you'd have Japanese and Polish. And you guys get the point. It's going to be all of these inside each of these dictionaries, and that's it. So I'll just do that for the sake of time. And just put these here so that you guys understand if you look at it in the future from Avenue. And we'll save that, and we'll move on to the next. So if anybody has any questions about it, feel free to ask. If not, we're going to go to subset sum. Subset sum, this is a pretty fun problem because it's getting a little bit more mathematical in the approach that some of these questions have. And this is a bit more of a typical programming question that you might see on LeetCode or HackerRank or any of those problem-solving coding websites. So what we have to do is determine if there are any two numbers in the list L, which is given, that sum up to the value S. So you can see some of these test cases. We're given a list 1, 2, 3, and we would return true if there are two unique, or like two distinct elements that sum up to the target, which is 5. So this is true because we have 2 and 3. This is false because no two elements sum up to 5. And this is true because we have 3 and 3. But keep in mind that if this test case was just 3, then this should return false because we cannot count the same element twice, right? So this would only be true, in fact, for the original test case, which is 1, 2, 3, 3. So the way we can do this is just simply by iterating over every pair of numbers in a list. And that's very easy. You can just you could just say for I in range length of L, and we'll do a nested one to get inside there, and we'll say for J in range of length L. And so now we have a nested loop, which is going to iterate over every pair of elements. But keep in mind there's going to be overlap, right? I and J are going to start at 0, which means I and J are both going to be pointing to the same element. And keep in mind that we don't want to consider the same element when we check to see if they add up to this target. So we're basically going to be saying if L at I plus L at J is equal to S and I is not equal to J, then we'll return true. And if we get through that whole nested loop, if we get through every single pair without ever returning true, that means that we never found a valid pair, which means that we should return false because there is no valid pair of numbers that sum up to S. And this is the important part here. I does not equal to J because we want to make sure that we never count the same one twice, right? Keep in mind that here, this should return false. Maybe I should just add a new test case so you guys can see, right? This should be false, but the issue is if we didn't have this and I not equal to J, then our function would actually return true for this test case, which is incorrect because it should be returning false. Because there would be a certain point in this loop where I and J are both equal to each other. They're both equal to 2, which means L at I and L at J would both be pointing to the same element, but be summing up to 6. So we would return true, whereas we should be returning false. So that's why we add this extra condition here. Hopefully that makes sense to you guys. And we can define this function and then run it, and you see that all of our test cases, once again, are good. So this is starting to get into the trickier realm of questions. So obviously, if you have any questions about that, about the logic used or the understanding, feel free to ask. Here's the next question. It's called shortening sentences, and we have to write a Python function that removes all uppercase and lowercase vowels. So there's actually a pretty cool way of doing this. And a lot of you might have thought, okay, we're going to have some sort of list of vowels, right? It's going to contain all of the vowels, uppercase and lowercase. And then all we have to do is say for character in S, and obviously we're going to keep a result string for character in S. If that character is not in our vowel list, then we're going to add it to the result. And then at the end, we can just return our result. And you can see that basically we're using string concatenation to achieve this because we're starting off with an empty string, and we're going to loop through every single character in our sentence S. And if that sentence, if that character is not a vowel, uppercase or lowercase, then we're going to add it on, we're going to append it to this result string. And by the end of it, we would have appended every single thing that's not a result. And so the question is, how do you define this vowels list? You could do something like this, right? A, E, I, O, U, and then you do capital A, capital E, so on and so forth. But what you can actually do is you can actually just make it a string instead and do something like this. And the reason this works is because in Python, strings are actually sequences. They count as sequences of characters. And since they're sequences, you can actually iterate over them, which means that you can use the in keyword. Because all in does is it iterates over an iterable, in this case a sequence, and it checks to see if the char, in this case, is in this iterable. And so here we're just checking to see if char is not in that iterable. So it'll iterate over every character in this string and make sure that this character is not in it before adding it onto char. And by the end, we just return results, and we're good. Cool. All right, so yeah, basically this saves a lot of time instead of defining a whole list. All right, any questions? Doesn't look like it. We'll move on. So here we are. This is basically a harder version, not necessarily harder, just more involved version of the previous question. What does it say? It says we're only going to remove those vowels that follow another letter. In other words, we're going to keep every vowel that's at the beginning of a word. So we're going to remove every vowel, but if that vowel is at the beginning of a word, then we're going to leave it in. So how can we do this? We can say for I in range length of S. And actually, let's copy our vowels and our result over because we're going to need to use that again. Right? For I in range of that, if S at I is not in vowels, or S at I minus 1 is a space, then we're going to add on our character to our result string. So that's going to look like this, right? And at the end, we're just going to return our result. It'll be good. Now, there is a little caveat with this, and you guys might have already spotted it. You might have not. But this code is actually not correct. And hopefully some of you guys can see why. I'll start by saying this. The range that we're iterating over is from 0 to the length of S, not including the length of S, right? So we're starting at 0. But keep in mind that we're checking, right? We're accessing S at I, but we're also accessing S at I minus 1. So if I starts at 0 and we're looking at I minus 1, we're looking at S of negative 1, which is the last character in the string. But we don't want to be doing that because we want to be looking at the character that is directly preceding any given character in the string, right? So basically, this is an edge case because it only happens at a certain edge of the program's input, and that's what we call edge cases. So it's a special case that we have to consider for when I is equal to 0, right? Because then this is not going to work as we intend it to. So to resolve that, all we have to do is we could just say, or I is equal to 0. Basically, if I is equal to 0, then we're going to add that character on anyways, right? And now if we run this, we're all good, right? If we take this out, you'll see what happens. We actually get false for these first two. And the reason for that, as you can see here, if we just call this here, oops, forgot to print it, sorry, is the output string that we get is actually missing that first I. And the reason it's missing the first I is because we're only adding it on if s at I minus 1 is equal to a space. But s at I minus 1, when I is equal to 0, is actually pointing to the last character in the string, which is L, which is not a space. And this is not the intended behavior, so we need to add in some sort of way to basically say, hey, if I is equal to 0, aka we're looking at the first thing in our sentence, then we want to always include that in our result. Because by definition, the first character of the sentence is obviously going to be the first character of a word, right? And the question asks you to keep any vowel at the beginning of a word, and obviously any character at all at the beginning of a word. So yeah, that's why we do that. And rerun that, and we're good. So hopefully no questions about that, but if you have any, feel free to ask. We'll keep going. So here we've got university majors, and this question gives us a dictionary and a person's major. And we want to find out whether or not the given person is majoring in the given subject. And we return true if they are, we return false if they're not. So I believe we can do something like this. We can say, so how does a dictionary look? You can say if name is in the dictionary, so majors dict, then we can write in here if majors dict at name is equal to the major that we're given, right? Return true. And if that never happens, we can return false. So let's see if that's right. Yeah, it's correct. Keep in mind that the reason I do this is because if we try and access a dictionary entry that doesn't exist, Python will actually throw an error. So you can see that if we just remove this part here, we tab this over, if we passed in another test case with a name that doesn't exist, for example, Basil, Python throws a key error because a key error basically just means that you're trying to access a dictionary key that doesn't exist in the dictionary. So that's why before I try and access a dictionary key, you should always check to see if that dictionary key exists in the dictionary in the first place. So that's why we say if name is in majors dict, because then we're checking out the keys of that dictionary first. We type everything in, and that's good. Right. That's supposed to be false because Basil does not exist. All right, we'll save that and move on. So once again, a very similar question. Given a dictionary that instead maps majors to lists of names, repeat the above question. So here it's the same question. We're trying to return the same thing. It's just that now the format of our dictionary that we're provided with is a little bit different. So we can check it out. Basically, previously, we had a dictionary of names to majors, name to major, name to major. Here we have a major mapped to a list of names that a list of names of people who are in that major. So here we would just say if name in major dictionary at major, return true. If not, return false. And let's see how that could fail. Can we possibly get a key error when running this? That's what you should always ask yourself when you're trying to evaluate whether your code for a dictionary is correct, right? I assume that, yeah, I think you can actually assume that they're always going to give you return false if okay, here we go. Return false if the student is not in the list of students. Okay, so this was actually correct what we did here, because you can actually get students that are not in the list of students, which is good. And so here, I assume we can do the same thing, which this already does, right? Because we're returning false if the name is not in that list. But what we can also do is we can have a safeguard against majors that are not in our list as well. So we can say if major not in major underscore dictionary, and we can tab this in. So basically, if major is in the major dictionary and that name that we're given is in that major's list, then return true, if not return false. So that's right. And this way, if we are passed in a major that doesn't exist or a name that doesn't exist, both cases will give us a false, which is what we want, right? So here, if we say Basil again, and let's make a fifth test case that has a name which is correct, but a major that is not correct, like fishing, spelled wrong. Let's try that out. So perfect, our function returns false in both of those cases, instead of raising an error. Keep in mind that when you raise an error, obviously if you raise an error when you're not supposed to, the autograder is always going to grade you wrong for that question. So always try and avoid errors if you can, if we ask for it. So here we specifically asked for it, which is why I did that. And these should be false. False. Did I mess it up here as well? I did. Yeah, no, that should be false. Okay. And this should be false as well, and we get everything right. So, okay, checksum. So in computing, a checksum is a simple but effective way to verify the integrity of transmitted data. Given a list of data and a checksum value, return true or false based on whether the data matches the checksum value. To compute the data from the checksum value, compute the sum of the list and compute the 4 least significant bits of the sum, and return from the function whether or not these 4 bits match the checksum given as an argument. Okay, so this question was also very commonly asked about in CompSci, or sorry, in Piazza, and for good reason, in my opinion, because I think this is a really hard question for people who are not CompSci majors or have a decent background in computer science or software, because it involves some pretty tricky operators. So here we do give you a hint. We ask you to take a look at the bitwise operators page of the Python documentation. So if you go over here, you'll see that they talk about these operators. Here we have x and y. So they talk about the bitwise AND operator, which basically transforms both of its arguments into binary, and then bit by bit, it goes over them and it returns 1 for each bit if the 2 bits provided AND up to 1, which means that they're both 1, and otherwise it returns 0. So I can try and explain that a little bit more. We're basically going to want to define our data as the sum of that list that we're given, just like we're asked to. It says given a list of data. To compute the data from the checksum value, compute the sum of the list. And now what we want to do is we want to AND it with four bits at the end, because we want to isolate the 4 bits on their own. And the way we can do that is by just declaring a binary number, just like this. So if we do that, we're basically going to have the 4 last bits of our data on their own. And at that point, we can just return whether that data is equivalent to the checksum value that we're provided with. And that's enough for that question. So keep in mind what this is doing. I can explain this, right? 0b111 is equal to the binary string 111 in binary digits, bits, right? And so basically what's going on right here is we have, let's actually rewrite this because we don't need to write it twice. We can just say sum of L like that. So basically we have sum at L, which is equal to some sequence of bits, right? Any sequence of bits. It can be something like this, blah, 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 all the way up to the last 4 bits, which are the least significant bits, right? And let's say, for example, let's say the least significant bits end up being 1, is equal to just 1111, right? It's all zeros and then 111 at the end. And so what's going to happen is when we AND those together, we're going to get 1, 0, 0, 1. In essence, we're isolating the 4 least significant bits of our checksum data, which is exactly what we want, right? So in this case, this is 1 plus, this would be 2, 4, 8, right? So here we have 9. So in this case, it would return 9, which in hexadecimal would, that would just be 0x9, right? Something like that. And that's it. So I'll just say here, for example. But yeah, basically, this is the whole problem, right? And I'll just put that here. And if we define that function and run these test cases, everything's good. So yeah, just to reiterate, guys, this is a really hard question, and in my opinion, shouldn't have been on the assignment. But don't worry, I think that Mr. Moore is going to go a lot easier than questions like these when it comes to tests, especially, and future assignments, hopefully. So don't worry about something like this popping up frequently, because it should not. But if you did manage to get this correct, then congratulations, because it was really tough. So moving on to the last question, which is actually the bonus question of this assignment. This was a bit of a tedious one because we actually had to go over a lot of translating and it involved a lot of dictionaries. But still not bad. So basically, we can take a quick look at the question. We are trying to convert a English sentence to leet speak, which is basically tells you here that we're just basically turning our sentence into a list of words, as a hint, replacing each word, turning it back into a sentence, and then replacing each letter individually as we need to. And it tells us the syntax of how we can use the join command to join a list of words into a single string, right? Blah, blah, blah. Gives you a little hint here. This hint actually, you don't even need the dot keys. If you just do if word in dictionary, it will reference the keys by default. So moving on, we have basically it provides you the mapping of words that you want to replace. So elite is going to become elite, so on and so forth. All these words are going to get transformed. And then after we've replaced any of this stuff, then we want to replace the letters at the end. So here, after we've replaced the words, we're going to replace every A with an at, every E with a 3, and so on and so forth. So the way to implement this is, of course, in the most simple way, using a dictionary, because we can hold a dictionary of mappings between every word that we want to replace with the word that we want to replace it with. And similarly, we can have a dictionary that maps every letter that we want to replace with every character that we want to replace it with. So, I have pre-wrote this dictionary just to save some time. Just like this. And actually, let me find a neater version of that so that it's a little bit more easy to understand. So here we can define a elite word dictionary with all of these string mappings. And then we can also define a dictionary which contains, as I said, the mappings for characters. Just tab that back. And then at that point, we can actually start coding our function. So let's see what the process is going to be. We're going to turn our sentence into a list of words, and then we're going to replace those words. So first we can say, let's call it original words because we're referring to the original sentence before any replacements have been made, and it's going to be a list of all the words in that original sentence. So we're going to say, we're going to acquire that by splitting our given sentence S by a space. And once we have that, it's pretty easy. We can just say something like for I in range, for I in original words, if, or actually let's call it word, right? For word in original words, if word is in the dictionary, or actually, you know what? Let's not do a for each loop. Let's actually iterate over the range of the length of this list. And the reason I'm going to do that is so that I can actually access the index of the list that I want to replace, right? So it'll be something like this. And here we're going to use an indexing variable again. So it'll be for I in range length of original words, if I, and so now we're going to say if original words at I is in elite word dict. And now you guys are going to see why I used the range instead of doing a for each loop. Now we can say, we can replace that spot in the list by referencing the actual index that we're using. By saying original words at I is equal to elite word dict at original words at I. And the reason we can do this is because we have access to the indexing variable, which gives us the actual index in that list of the word that we're referring to. And so you can see here that we're referring to the specific word that we want to replace, and we're replacing it with the value of that word in the dictionary. So if that word that we found was own, for example, we would replace it with the value of that word in the dictionary. So it would be this word right here, own. So at that point, we've replaced every word that we need to replace. And so I think we can probably just join them back up at this point. So something like this, dot join original words. And here we can call this new variable replace words. And what else do we need to do? Now we need to go ahead and replace every single character. So we can do another loop here, once again using the range. Replaced words. Let's see. So now we want to say if, or sorry, this is not going to be words. This is going to be the replace sentence. So we can call this updated string, for example. I'm just trying to find a good name to call it. And we're going to say if updated string at I is in our character dictionary, then we're going to replace that string, or sorry, we're going to replace that character with the corresponding value of that character in our dictionary, which is what we want to replace it with. Just like that. And how do they want us to finish this off? I believe that should be good. Ooh. Okay, so this actually might not be good, and this is actually a good learning moment because I'll be able to show you guys why this might be wrong. So if we go ahead and try and return our final string, just here, we might see an error. And so if we return updated string, yeah, so we're going to see string object does not support item assignment. And the reason for that is because strings, as you guys should have learned in class, are actually not immutable. Strings as an object type are one of the few immutable objects in Python, which means you cannot change them directly. You can update their value, but you cannot iterate over a string and change each character one by one in that string. So the way we can do this is very simple. We can do something like this. We're going to basically cast this to a list. And this is basically just kind of like a cheap shortcut because while we know that strings are immutable, we also know that lists are mutable, which means we can change lists. So instead of representing the updated characters as a string, which we can't change, how about we just instead represent it as a list, which we can change? So at that point, all I have to do is just change these. Right, and so at this point in the program, after we did this for loop, we would have replaced every single character in this list. And so all we have to do is cast this list back into a string by saying final string, and we're going to assign that new variable the value of our updated chars casted as a string. Okay, that did not quite work because we failed everything. But it's okay because we can use our debugging skills to find out why in these last 5 minutes. Let's check it out. Oh, we did not return final string. We should update our return value. Okay, still no good. So let's take a look. We're going to print out this. Oh, that's not good. Oh, okay, yeah, sorry guys. So the way to cast a list back to a string is actually not using the string, it's using the join function. I completely forgot about that. So we're basically just going to join our updated chars list with nothing as a separator, meaning that it's going to glue them all back together. So if we run this, we're a little bit closer now, but what is still wrong? Very well acquainted. Matters mathematical. Oh, thank you. Thank you, Juhu. Yeah, that's right. If any word ends with an S, replace it with Z. Yep, so that's one that I just missed. So that's easy. Just here, we'll say if updated chars I is equal to, what is this? Just S. Becomes Z. Still no good. Oh, it has to end with an S. Yeah. So we'll say ooh, yeah, okay. All right, so I kind of see what I might have done here, and I tried to replace every string in the character, but the way this might not work is because now we don't really know when a word ends because we're not doing it word by word. So what I should have done is I should have actually done this replacement inside the words, but you'll see that we can actually do something a little bit clever by just saying if updated chars at I is equal to S and updated chars at I plus 1 is equal to a space, or updated chars at I, or I is equal to length of updated chars minus 1. Still no good. I thought that would work. So what I'm trying to do here is I'm trying to only replace it if it is the last character of a word, which I thought by checking the next character to see if it's a space or if it's the last character of the string would work. Oh, it's a dollar sign. Okay, so if we just replace this with a $sign, we get the correct thing for the first two, but we go out of range. Yeah, and that's because we are trying to access I plus 1 when we can't always access I plus 1. So the way to fix that would just be to add a guard. So we just have to make sure that I is greater, or sorry, is less than or equal to, or we just say less than length of updated chars. Oh, we forgot to add this. Type error bool has no length. Sorry, guys. Let's see. What am I trying to take the length of? Updated chars. I forgot to close the brackets. All right. I think I'm making this a little bit more complicated than it has to be, just because I'm doing it outside of the words. Data chars. So yeah, realistically, what we can actually just do is we can do this. And we can forget this and forget this. And hopefully this works out. So basically what we're doing is we're just going up to, but not including the last one of the whole string. And then for that last one, we're going to say if updated chars at -1 is equal to $. Can't spell $, then updated chars at -1 will become Z. Let's see if this works. Matters mathematical. A little bit confused. What's the difference here? These both seem like they're the same to me, are they not? Right? Isn't this is there a space here? Oh, okay, it's the last one. It's the last one. Yeah, okay. Oops, we forgot to actually replace the last character. So this will just be here at -1, then -1, leet char dict updated chars at -1. Oh boy, this is very bad. Okay, we're almost there. One other test case, which is number 3. Let's check out this and see what's going wrong. All right, so once again, this is just, it should be Z. But for some reason, it's not changing my $sign to a Z. Are there any other mistakes? It looks like that's the only mistake. If updated chars at -1 is $sign, well, there shouldn't be any S's left, should there? They should all be $signs. I'm just going to do a bit of debugging here. We're going to check to see what the values of updated chars are. It's a $sign. Oh boy. Guys, yeah, so this is a very dumb error. Here you can just see we had a double equal sign instead of a single equal sign. One is assignment, one is obviously comparison. So if we print this now, we're all good. All right, sorry about that ruffle up for that last question. Done very poorly, to be honest, by me. I should have been a little bit more careful there. And just to reiterate, guys, this would have been a lot easier if before I had joined them back together as words, I would have done the replacement then, while they're still distinct words. So if you guys do something like that in the future, do it that way, because then you don't have to go through the trouble of trying to figure out whether a character is at the end of a word or not. Because you could just check to see if it's the last character of the word simply by checking to see if you're at the end of your for loop iteration. So yeah, that's it for this one, guys. Thank you very much for coming. Hopefully you learned something, and if you have any questions, feel free to reach out on Teams. And yeah, that's it. I'll post this up on Avenue for you guys to see it if you need to. And until then, I will see you guys at the next tutorial.